All right, I am going to learn C the old-fashioned way by using the original, second edition that is, C programming language manual written by Brian Kernighan and Dennis Ritchie. This is, I believe, an early 80s edition, and it's available free on the internet. You can look on archive.org. And the idea is I'm going to go through this, probably skim it, try to go through most exercises. I'll probably have to look up some stuff outside of it to understand what's going on. But I originally learned C back in college. I never completed college, so I never mastered C. My first exposure to programming was with BASIC on the TRS-80, Trash 80 Coco, back in 1982, I think it was. And my first exposure to C was in high school in the early 90s using the Borland C compiler. And it had a manual, but it didn't have a really good tutorial book. I was totally confused by pointers, especially. But also coming from a primarily basic background, I was even confused by this programming language doesn't have line numbers. In BASIC, you type 10, print hello, 20, go to 10. In C and modern programming languages, which at the time included things like Pascal, there was no such thing. So I haven't used C hardly at all since college. A little bit here and there. A lot of compiling Linux stuff back in the days, but not really anything. So I'm going to learn the fundamentals of C and Unix programming. Now, I have done a lot of programming. I'm specialized in test automation, and I've done a lot with Java, PHP, some Python, and C#, and of course, quite a bit of JavaScript, doing web development as well. And so let's jump into this, right? So I want to get this into single page view. Right, so single page, actually, what I want to do is take a minute here. Let's take a look at our table of contents, not just the full table of contents, but let's look at, so we've got the preface to the first edition. So chapter 1, we've got a tutorial. Chapter 2, we're going to talk about types, strings, int, char, etc. Operators, equal, not equal, greater than, less than, those kind of things. And expressions, how do you evaluate something is true or false? Control flow, if, then, while, for loops, functions, and program structure. So we're going to talk about functions, like starting with main, I assume. Chapter 5, we're going to learn about pointers and arrays. This gets into the trickiness, things that are more specific to C than your general purpose programming language. Structures, struct. A struct is a data structure. Input and output. I imagine we're going to do some, printf and read line, stuff like that. Looks like put char. Those are probably older ways of working with it. And then we'll visit C++ and go with C in and C out and stuff. And then talk about Unix, reading files, maybe sockets and stuff like that. And then there's a short reference manual. They stress in the preface that this is not a full description of ANSI C, but it's a summary for programmers. Talk about the standard library and the differences, right? So this second edition came out after ANSI C was standardized. With the first edition, there was no standard. And so it talks about differences. So let's jump into this. I've already read the first preface, but now let's kind of make this bigger so we can see it on the screen. Right? So let's try and fit it on so you can see my pretty face as well. All right, and then let's hide the sidebar as well. And that gives us a nice big view. Unfortunately, we've got all these gaps around the side because the heading is there. But anyway, so let's look at our chapter 1 introduction, right? Getting started, variables and arithmetic expressions. So, right, that's things like equals, greater than, less than. The for statements, so that's actually not in chapter 2, but a for loop. Symbol constants. We're going to learn what constants or symbolic constants. Character input IO, put char, get char. File copying. So these are things that are covered in more detail later, it looks like. But counting characters, string length, the infamous danger of C. All right. Arrays, functions, arguments, character arrays, strings, external variables, and scope. So let's go ahead and jump into chapter 1 here. Now I wish I had my my table of contents over here still, but I want to have nice big text to read. So we'll skip the preface to the first edition. Chapter 1, a tutorial. Let us begin with a quick introduction to C. Our aim is to show the essential elements of the language in real programs, but without getting bogged down in details, rules, and exceptions. At this point, we are not trying to be complete or even precise, save for the examples are meant to be correct. We want to get you as quickly as possible to the point where you can write useful programs. And to do that, we have to concentrate on the basics: variables and constants, arithmetic, control flow, functions, and the rudiments of input and output. We are intentionally leaving out of this chapter features of C that are important for writing bigger programs. These include pointers, structures, most of C's rich set of operators, several control flow statements, and the standard library. This approach and its drawbacks, I think it should say has its drawbacks. Most notable is that the complete story on any particular feature is not found here, and the tutorial, by being brief, may also be misleading. And because the examples do not use the full power of C, they are not as concise and elegant as they might be. We have tried to minimize these effects, but be warned. Another drawback, I'm probably yelling because I have my headphones in. Another drawback is that later chapters will necessarily repeat some of this chapter. We hope that the repetition will help you more than it annoys. So, like I said, that this is going to touch on things like I/O that you need to get started to print Hello World, and then I'll go into more detail later. In any case, experienced programmers should be able to extrapolate from the material in this chapter to their own programming needs. Beginners should supplement it by writing small, similar programs of their own. Both groups can use it as a framework on which to hang the more detailed descriptions that begin in chapter 2. All right, getting started. The only way to learn a new programming language is by writing programs in it. The first program to write is the same for all languages. Prints the word hello world. This is a big hurdle. To leap over it, you have to be able to create the program text somewhere, compile it successfully, load it, run it, and find out where your output went. With these mechanical details mastered, everything else is comparatively easy, right? So this is 0 to 1. We've got to have a C compiler. We've got to know how to compile it. We've got to have an editor. We've got to know how to turn our source code into compiled code and then how to execute it. And some of that's not going to be relevant from this book to our modern environment, but I'm going to try and keep it simple. I'm going to use the Linux command line. I'm going to use Vim. I'm going to try to keep it as basic as possible. So in C, the program to print hello world is pound includes stdio.h and then main printf hello world /n for new line. All right, so let's go ahead and go here. So I'm starting on my Mac here, right? And I should have GCC here. Good, so I've got GCC version and user bin GCC. So I'm just going to do Vim and stdio.h, and we're probably going to have to do like int main and return, but let's see what happens. We should always capitalize hello world, right? No, let's follow the example given to us. I want to make this full size as well so that we can see. Okay, yeah, it just has main printf, and let's observe this syntax rule with the brackets, which is the one true way. Printf hello world semicolon close bracket. Call this hello.c. All right, so you can see I've got a file called hello.c, and I can open this in any text editor. If you're using Windows, you can use Notepad. I don't know what Mac has, but I never use any Mac specific editors. And let's shuffle our windows around. We want parallels. Right, first I'm getting started on the Mac, make sure everything's working, and then I'll do it in Linux. So now we type cc hello.c. Let's see if cc is alias to cc. All right, so right, did I break it? Okay, yes. So CC and GCC, one is an alias of another, and they're the same thing. So it's Apple CLang version 16.0, blah blah blah. It's a C compiler. Okay, so let's do cat hello C pound include standard io.h main printf hello world, and you can see I forgot my new line. So I'm not going to try and use the inline editor. It does exist, though. I don't know how to get out of it. Oh, my goodness. Let's ask the internet. Exit from ed command line. Right, so I'm trying to do sigint. Why can't ed? So I'm looking at this. I guess you can't see it on that screen. Control C sends sigint. That's not Control C. Control backslash. Signal, sigint. Here's what ed does. Says ed uses Control C. Okay. All right. I got out of it. I think I probably hit Control Z. Yeah. All right. So yeah, I don't want to use the ed, so I'm going to go back into Vim. Vim hello C. I'm going to add my new line character on the end of my string for print hello. So that is /n. All right, so now I can do cc hello.c. Type specifier missing defaults to int. ISO C99 do not support implicit int. So I could do, let's see, did it create an output file? Nope, it did not. So if I do, as it says, dash W, implicit int, implicit int equals true, maybe. One warning. I'm looking for an A out. What if I try it with GCC? I want to try and follow the old, oops. All right, let's go back to our internet. How can I make GCC allow implicit return type to be to work like C and R? All right. Because I want to follow the examples. We can do the dash ANSI flag, I think. There we go. Okay, so if I do this, all right, so now if I do cc hello.c, it compiles without any errors or warnings, and we have an a.out file, right? So I can, we can look at a.out. We need to do the dot slash before it. And it prints hello world. We throw another tab on here. And, right, so now I have two nice little windows. One is my editor, and one is my compiler. Oh, all right, now we'll try this one more time. All right, we got our hello C here. Now what I want to do is I want to change this. All right, it says to experiment. I'm going to make hello capitalized. And I need to remember I could just type :W. And then I can switch tabs, and I can and then I can do, right? So I've got my, right? I built myself an IDE. I've got my editor window. I've got my compiler window, which even has the bonus of having my terminal output. Wow, this is better than VS Code. Okay. Let's go to our next step, right? We successfully created a hello world. Yes. Now we've compiled it. So just how to run this program depends on the system you're using. As specified, the Unix operating system, you must create the program in a file whose name ends in .c, such as hello.c. Then compile it with the command cc hello.c. That's what we just did. If you haven't botched anything, such as omitting a character or misspelling something, the compiler will proceed silently and make an executable called a.out. If you run a.out by typing command a.out, and as you remember, we had to type the start from this directory, we could do export path equals dot colon path, right? Now I can just do a.out and it prints out. What I essentially said here is use dot, the current directory, as the first directory to search in our path of known paths where we can execute files. So we're getting closer to what CNR has. We can do cc hello.c and then we can do a.out. All right, we're looking good here. Let's see what's next. If you haven't botched anything, okay, it will print hello world. On other systems, the rules will be different. Check a local expert. I guess I am the local expert. I knew about the /. Now for some explanation about the program itself. A C program, whatever its size, consists of functions and variables. A function contains statements that specify the computing operations to be done, and variables store values used during the computation. C functions are like the subroutines and functions in Fortran, Fortran, just like we're used to, or the procedures and functions of Pascal. In the case of BASIC, well, you've got goto, and then you've got go_sub, which creates a subroutine at a certain set of lines, and then you can return. So if I have 10 print hello, 20 go to 7,000, it jumps to line 7,000 and it says print goodbye, and then line 7,010. You always jump by 10 in BASIC, so you can fit up to 9 commands in between this command and the last, because there's no moving commands around in BASIC. It's very line number oriented. Anyway, and then you can do return. A return in BASIC will return to the line that called the go_sub. It will pop the stack or whatever. And then you're back on line 20, which completed, and will execute the next sequential command, whether it's 21, 30, or 3,000 or 7,000. All right. We're not learning BASIC, though. We're learning C. BASIC didn't have functions, and that's one of the nice things about C. And it didn't have line numbers, which also means you don't have to worry about fitting things into a certain space. Our example is a function named main. So we look here, we see the name of the function main, and we have the curly brackets, or not the parentheses, are the arguments to main, and it has the return type before, which is why you would normally see int main, right? And we're ignoring that for now. Actually, we'll go ahead and add that. And then I can, yeah, and it still works. So we've got a function called main. Main is the entry point to any program in C. Normally you are at liberty to give functions whatever names you like, but main is special. Your program begins executing at the beginning of main. This means that every program must have a main somewhere. Main will usually call other functions to help perform its job, some that you wrote, others from libraries that are provided for you. The first line of the program, pound, include stdio for standard input output, .h, tells the compiler to include information about the standard input output library. The line appears to be telling at the beginning of many, the line appears at the beginning of many C source files. The standard library is described in Chapter 7 and Appendix B. One method of communicating data between functions is for the calling function to provide a list of values called arguments to the function it called. The parentheses after the function name surround the argument list. In this example, main is defined to be a function that expects no arguments, which is indicated by the empty list, the brackets. So here is the listing of our program. It says include information about standard library, define a function called main that receives no argument values. Statements of main are enclosed in braces. These braces are the curly brackets that we often call them today. Main calls a library function printf. So printf is a function name that's included from standard IO to print this sequence of characters. This is the sequence of characters within the quotes. Slash n or backslash n represents the new line character. So hopping back over to our program, switching to our editor view, right? If I did hello world /n/n/n, write that, and I don't know the command shortcut to switch, but is it shift? I need to experiment for a second so I can get between. All right, I wanna get between terminal windows on Mac. All right, I'm gonna take a minute to how to switch between tabs in Mac terminal. Command Shift bracket. There we go. So I can do Command Shift right bracket, Command Shift left bracket. And now I can switch back and forth without having to mouse over it, right? And now if I do a.out, did I write this? Oh, I didn't recompile. So I can also do this. So this means compile and execute. And you can see it prints a couple of extra new line characters at the end. If I don't have any new lines, right, if I just have hello world, then we can see, this, which is the start of our shell command, is at the end of hello world on the same line. So let's fix that. And now we can see, all right, this is not actually, I mean, it is the shell character, but this oh my bash or oh my zsh or something like that, right? It doesn't know what to do with this. It prints this on the next line. Anyway, so by adding a new line character, it doesn't trail over, and because I'm using oh my zsh, that it behaves a little more unexpectedly. The rest of this comes on the next line. All right. Wait, now it's working. Control Shift arrow keys works now. I don't know why it wasn't working before. All right, so that's our first C program. The statements of a function are enclosed in braces or curly brackets. The function main contains only one statement, printf hello world. A function is called by naming it, followed by a parentheses list of arguments. So this is called a function printf with the argument hello world /n. Printf is a library function that prints output, in this case the string of characters between the quotes. A sequence of characters in double quotes like hello world is called a character string or string constant. Strings, as we normally call them. For the moment, our only use of character strings will be as arguments for printf and other functions. I assume we'll learn more about it later. The sequence /n in the string is C notation for the new line character, which, when printed, advances the output to the left margin on the next line. If you leave out the /n, a worthwhile experiment, which we just did, you'll find that there's no line advance after the output is printed. Let's try this. If I just go to bash right? And then I go, and now I do CC. I think I'm going to, okay, it worked. And now I do A dot out. So I didn't lose my alias for CC with the dash ANSI flag, or my path with the A dot out, switching between bash and ZSH. All right. So going back over here, let's remove our new line. Oops. And now you can see more clearly. Hello world bash is all on the same line. And then I'm going to exit to go back to my preferred terminal shell. Let's see. Okay, I guess let's start here. I probably here we are. If you leave out the /n or \n, a worthwhile experiment, you will find that there is no line advance after the output is printed. See here. You must use /n to include a new line character in the printf argument. If you try something like printf hello world, and then on the next line, close quote, close parentheses, semicolon, the C compiler will produce an error message. So let's try that out. Oops, I forgot I have my separate terminal window. And then we get warning, missing terminating quote, error expected expression, missing terminating quote, error expected close bracket to match opening bracket. So we're confused, right? Our compiler's parser is confused, I should say. Printf never supplies a new line character automatically, so several calls may be used to build up output line in stages. Our first program could just as well have been written printf hello, printf world, printf new line. Okay, so let's do that. I've got that right, the different keys. So so do printf, and we'll go back to lowercase hello. We need printf, not just print. And then we're going to do our new line. And then you can see expected semicolon. Uh-oh, I missed my semicolon, huh? Oh, for these other lines. Each line needs a semicolon at the end in C. And you can see we don't have a space between hello and world because of things. So let's take a look at how they have it. Okay, they have hello, comma, space, world. So I hit escape, escape colon W will write, and then colon Q or colon WQ will quit as well as write. So colon, so if I hit I for insert mode, I can type, right? And then, actually I was using the delete key. What is it? Now to delete this, I hit escape to go from insert mode to edit mode. Now I can hit X or shift X or uppercase X will delete back, right? So in Vim, I have some characters I need to delete. If I need to delete something after my position, I hit, I go click escape, and X will delete after my cursor, shift X will delete before my cursor. So I need one more after, and I can do my quote there. And then I hit, after I'm done editing, I hit escape again, and then I can hit escape colon. This is command mode. So there's 3 modes in Vim. There's command mode. I may be naming them wrong, like this. The control or the colon W. Most commands start with a colon. There's insert mode. When I hit I, I'm in insert mode. When I go back to escape, the default mode is edit mode. I can move around and edit with that X and Shift X. And then lastly, when I'm done, I escape colon Q or W or WQ, and then we can do it. All right, and we can see it does hello world all in one line, even though it's 3 lines of code, because only when we have a new line character does it actually print the next line. This gets annoying a lot of the time, but there's reasons for it. And that reason is you might have multiple lines building up a string, a sentence, or whatever. Oh. All right. Note that \n represents only a single character. An escape sequence, escape meaning the backslash, which is backwards, I can't tell, provides a general and extensible mechanism for representing hard to type or invisible characters, like the new line. Among the others that C provides are \T for tab, \B for backspace, \quote for the double quote, right? Because our double quote is an important character in our code to delimitate all of our character strings. And \backslash for the backslash character itself. So if we want to actually write some of these characters, we can print F, right? Inside of our quotes, I can do \. Here, let's do this. Right, so I want to print F, \quote, and then quote. So what we're seeing here is I have a quote to start my character sequence. Then I have 2 characters, the \, and the quote, which represents just the quote character, right? It escapes. The escape sequence means the character after the the quote, is not read by the compiler or the interpreter. And then lastly, we have a quote to end our string. We're going to need a semicolon on the end of that. And then we can print, and then we want a \, because we want to print a \/ character. And then we want our /n for our quote. So now, when we write this and we hop over here, implicit declaration of function print. Okay, so I missed I missed an F. Here we go. That's why lining things up is nice, okay? So I'm gonna write that, hop on over here to my compiler. And so now we see we're printing hello world /n, and I didn't print an extra, right? We're printing a quote, we're printing a \, and then we're printing an N. And I could also do this. So another thing, right, I'm in insert mode. I move around, I hit escape, and now what I want to do is I want to hit YY. And then I move down here and I hit P. When I'm in editor mode, Y stands for yank, so I'm yanking a line. Two Y's is a yank. And then down here, I'm P for pasting, right? Likewise, with the Y, I can also do, is it X or D? Oh, X is a single character. DD will delete a whole line. So we write this, we hop on over here. And here's what I'm going to do is I'm going to do clear and compile hello C and a.out. And now we see it clear, and it prints quote hello world \n quote, right? Just a silly way of showing you how you can print those characters that mean something to the compiler that would otherwise represent something that's going to be parsed. All right, we'll see what's going on over here. Super small PR, 3 files, a couple dozen lines of code. Wait for URL to contain. Oops. All right, just a little quick code review. Okay, looks like we jumped ahead. Okay, note that /n represents only a single character, the new line character. Right, it's an invisible character. Run hello world on your system. Experiment with leaving out parts of the program to see what error message you get. Maybe I should do more reading and then wait till the exercise to do it. But it's also kind of fun to hop back and forth and mess with things like escape sequences and multiple lines. Experiment to find out what happens when prints or when printf's argument string, so I think the print's argument string contains /c, where /c is some character not listed above. Okay, so let's try /c, and let's also try print s and see. Oops. Unknown escape character sequence. Okay. Let's see what printS does. I don't know printS. Did you mean printf? Okay. So I think that's just a typo in the book. And then it prints Haya on the next line. All right, someone would rather check the URL that it contains a substring instead of check for an actual element on the page. It looks like my OBS is getting tired. Maybe my Mac is getting tired. All right, so let's see. Variables and arithmetic. The next program uses the formula, percent or degrees Celsius, 5/9 of Fahrenheit, degrees minus 32. So it's converting temperatures between Celsius and Fahrenheit to print the following table of Fahrenheit temperatures and their centigrade or Celsius equivalents. All right, so 1 Celsius is negative, or 1 Fahrenheit is negative 17 Celsius. 20 Fahrenheit is negative 6 Celsius, right? And on and on. Okay, the program itself still consists of the definition of a single function named main. It is longer than the one that printed hello world, but not complicated. It's a little more complicated. It introduces several new ideas, including comments, declarations, variables, arithmetic expressions, loops, and formatted output. So let's see, what are we going to call this file? Let's jump ahead and see. So this is something else. Print Fahrenheit Celsius table. So we got CC hello. See, I'm just trying to see the name of the file. It doesn't give me a file. Okay. So let's hide our sidebar. Let's jump back up. Okay, so let's take a look at this first before we type it, right? Pound include standard IO. We've got a comment, print Fahrenheit Celsius table for 0, 20, 300. Main is our main function. Open our function with the curly bracket or the brace. We have 2 integers named var in Celsius. We have 3 integers named lower, upper, and step. We set values for lower, upper, and step. So it's going to print 0, 20, 40, 60, up to 300. Okay, now I see this. This explains it a little bit better. The 1 is a little surprising. We'll see if that happens. Right, and then we've got Fahrenheit equals the lower temperature. So we're starting with the lowest temperature in Fahrenheit, while Fahrenheit is less than or equal to the upper, so less than or equal to 300. Celsius equals 5. The asterisk is a times symbol. And then we parentheses, right, in math, parentheses. Order of operations, multiplication happens before subtraction, but we want to do our subtraction first. So we Fahrenheit minus 32 /9. So 5/9 of our Fahrenheit minus 32 temperature. And then we print our output, our Fahrenheit value, and our Celsius value. And then we go on to the next value. We add 20. So if it's 0, it's 20. If it's 20, it's 40. Okay, this looks like a fairly simple program to implement. We'll see if we can do it in one shot. First, let's clean up our Hello World program. All right, so I'm going to hit D, and I'm going to just go to printf, escape, I for insert. Actually, I'm going to, /n. All right. Oops, and I don't need to do that because I've got my separate window for compiler. You know, I don't like doing clear at the beginning because if I have any errors, then I won't see them. Okay, my Hello World is working again. So I'm going to hop back over here, and now I'm going to quit, and I'm going to just call this temps.c. Let's be temperatures.c. All right, so hit I for insert mode. You can see that there. Oh, I must have lost focus. Oh, it was hidden. Pound include stdio.h inside the greater than less than brackets. C has a lot, right? It has parentheses, it has curly brackets, it has angle brackets, as they're often called, for the greater than less than when you include something. And there's also going to be the square brackets, right? Square brackets, curly brackets, or brace. So brackets, braces, parentheses, and angle brackets, or it's greater than less than sign. It's going to use all of these things to denote different groupings, all right? So we're going to main, doesn't take any arguments, implicitly return an integer. We've got our brackets to signify everything, and I'm going to go to escape to go to command mode. I'm going to do set tab stop equals 4. That's a little better. Instead of 8's the default. So what do we have? We have int var in Celsius. And then we have int, what do we have? lower, upper step, I think. And then we do, right, so we've got to declare our variables. And right, we could declare these all on one line, but separation of concerns, these two are our temperatures. These ones indicate how we're iterating through our temperatures. So we're going to set lower equals 0, equals 0, upper equals 300, and then step equals 20, or yeah. Each line ends with a semicolon, and then what do? We say while lower less than or equal to upper. Then we want to do we do Fahrenheit equals is it I don't remember how they do it. How would I do this? I would do lower time step. Oh wait, no, I think it's probably plus equals, right? So do I need to start with Fahrenheit equals 0? No, we're not defining Celsius here. So we can do Fahrenheit plus equals, actually, so that happens at the end of our function. So let's go ahead and add that, right? The last thing we do in our function is we increment by 20. So we make Fahrenheit, so actually we want Fahrenheit is less than or equal to upper. And then we do Celsius equals 5 times Fahrenheit minus 32 divided by 9. So 5/9 of our Fahrenheit. I think I was able to get that correctly. Let's check this out. So then what we want to do is we want to print. So we're going to print f parentheses, right? So this is our argument. It's a string. And then we can do %d, which stands for digit, I think, or decimal number, whatever. And then we'll do a dash, \t for a tab, and then Celsius. All right, I probably got something wrong, but let's try compiling this and see what happens. Oops, we don't want to do hello. We want to do so we compiled it, that worked, and then so we're going to add this and a.out to execute it. Okay, so it's printing something. I haven't checked it yet, but let's hop back over here. What I want to do is I want to add my new line. So each line should have a /n on the end, :w to write that. All right, so let's take a look at this. Fahrenheit 0, Celsius -17, Fahrenheit 20, Celsius -6, Fahrenheit 100 equals Celsius 37, 30 or 300. So it stopped at 300. That's good. And it stopped at and then stopped. So Celsius 148. Let's go back and check and see if we got the right numbers. Okay, so we've got 300, 148. Now note here this 1 instead of 0. Right, -17. I wonder. Let's calculate this. So outside of my loop, I'm going to do Fahrenheit height. And I'm going to, right, so here I'm going to put 1 is my Fahrenheit number. Actually, I'm going to do, so right after my loop goes all the way up to 300, I'm setting it back down to 1 instead of 0. And now I'm going to calculate this and see if it's actually the same. I bet it's going to be different. I bet it's going to be a couple degrees Celsius difference, or at least half a degree difference. So now we can do 5 times maybe it's going to end up the same. All right, so let's check this out. Oops. I'm going to go back over here to... Okay, so it actually... celsium, another typo. It is actually, right, it's 9/5 different. Or 5/9, I should say. So a little bit more than half a degree difference. And so Fahrenheit 1 is still -17. So that's not wrong, but we're not expecting 1 to be our output here. We're expecting 0 to be our output. So let's see if I did this correctly. Let's add our comment in here. So I'm going to grab this. Note the // So I'm going to do I and print Fahrenheit, Celsius table for Fahrenheit. Oops. So I quit without saving it. All right, let's do a little visual comparison. So we've got our pound include standard IO. We've got our comment. Notice it starts with // not backward / asterisk, and then it ends with asterisk /. This is a comment. The compiler ignores it. This is just for us to read. Okay. And then we've got our main. We've got our brackets, int var Celsius, int lower upper step, lower equals 0, upper equals 300, step equals 20. Let's add our comments here as well. Not bad for doing it from memory. All right, so we've got our comments here. Okay, we've got far equals lower instead of far equals 0. That's better, because now I can change my lower limit in the future. Right, I could have just changed my lower to 1. So if I go up here, and now we'll get the output we expected. Let's finish our comparison. Far equals lower. We'll DD to delete that extra new line. So while Fahrenheit is less than or equal to upper, Celsius equals 5 times Fahrenheit minus 32/9. And notice how the spacing doesn't matter here in the expression. Printf, %d, %t, or percent. So it's not actually printing out Fahrenheit and Celsius. And there's no space, just so it's printing. Oops, I wanted to keep that. So I'll go into command mode and hit U for undo. I can undo as many commands as I want, but that's enough. So And then our last line is Fahrenheit equals Fahrenheit plus step. So I did plus equals. That's a shortcut. Older versions might not have had plus equals, actually. So now I think we've got something that looks very close to what that is. Oh, very interesting. They have the bracket up here on this line, but not in main. Okay, very interesting, might be a stretch. Oops, I managed, no, I didn't manage to delete that. I managed to just hide it. So now we can line that up a little bit better. So I think the convention in K and R is functions. The braces are aligned, and blocks like a loop, they are not aligned. It's next line. Okay. Just to make sure we didn't mistype anything. Okay, so now we see, and then you can see here, that doesn't quite work because it adds a +1 to everything. And there we go, we've got 0 to 300. So, all of that to just say there is a typo in this output. Even though the value, -17, is technically correct because we're not doing any rounding on fragments of a degree difference. But the rest of the values are correct. Okay, the two lines are a comment. We already went through this, which in this case explains briefly what the program does. Any characters between the /* and the */ are ignored by the compiler. They may be used freely to make a program easier to understand. Comments may appear anywhere where a blank tab or new line can. In C, all variables must be declared before they are used, usually at the beginning of the function before any executable statements. A declaration announces the properties of variables. It consists of a name and a list of variables such as int Fahrenheit, int Celsius. So we could actually, hopping back over here, I don't believe that's completely true. Like we could do int lower equals 0, upper equals 300. And we'll just do that there. And you can see that still works. And to prove it still works, we can change our step to, we'll go step 10 degrees instead. And so it still works. So technically it is correct. You have to declare them before you can assign them, but you can also declare and assign on the same line. Assigning multiple variables with values on the same line is bad form. Makes it hard to read. It would be better to do this int upper equals 300 and int step equals 10. That's much more readable. And then we could include our comments in here. And we could say the lowest temperature the highest temperature and the increment between temperatures. Let's change this back to 20 just to make sure that our output, so we're assigning Fahrenheit because this is part of the loop. We hop back over here, we clear our screen, we compile it and print out, and you can see we're back to 20 based increments. All right, good enough. Okay, so comments All variables must be declared before they're used, usually at the beginning of the function before any executable statements. A declaration announces the properties of variables. It consists of a name and a list of variables such as int var, int Celsius, int lower, blah, blah, blah. The type int means the variables listed are integers, by contrast with float, which means a floating point, the point meaning the decimal point, numbers that may have a fractional part. The range of both int and float depends on the machine you're using. 16-bit ints lie between negative 32,768 and positive 32,768 are common, as are 32-bit ints. A float number is typically a 32-bit quantity with at least 6 significant digits and magnitude generally between 10 to the negative 38 and 10 to the 38. C provides several other data types besides int and float, including char for character or a single byte, right? A character is stored as a single byte. Up to 256 bits are in a, 8 bits are in a byte, which means you can have up to 256 characters, although ANSI C only has 128 characters, or ASCII. Short integer, long integer, double precision floating point. So let's try, let's hop over here and looking at our program again. We're going to make our lower, upper, and step are going to be kept the same, but we're going to change these from int to float. And so we need to change the %d to a %f. And then let's recompile our program and see what happens. Now you can see here it has, like it said, at least 6 decimal points of precision. And so, these are still whole numbers in Fahrenheit, but we've got more precision in our Celsius numbers, and you can see the difference here. If you divide numbers by 9, right, you get things like 0.111 and 0.222 and 0.333 and so on. You notice these last numbers here? It's rounding up or down. So there is some inaccuracy in that. Let's notice these numbers and let's create a new tab. There we go, new tab directory. And so I want to compare this output. If we change our floats values to double, so floating point to double floating point, and then we actually need to change this -f to percent %d is we got CC temperatures and A out. Defaults to int. Okay, so this time we lost it, right? Let's try this one more time. So yeah, so printf with double. Does it just use %f? LF. I guess that stands for long float. I was confused because I knew that %d was for integers, and %f was for floats. %lf is for, I guess it's long float. The L modifier is optional and has no effect when used f conversion. So I think we can just do printf or print %f. Printf %f. That failed because Oh, export path path uppercase equals dot colon $, our existing path variable. So now I can do CC temperatures and okay, so let's take a look at our numbers. 7778, 6667, and notice this is 111, 233, 44, 5, 6. It rounds up. So comparing oops, man, I messed up. So here's our double precision. And I need to go back and edit this again, and we'll make this into float. Okay, so here's our single precision. You know, you can see 7779 versus 7778, and 1111 versus 1115. So single precision floats are less accurate than double precision floats, right? It rounds them sooner, and that error trickles up in the precision. Okay, I think we're just about done for today. But that was an interesting sidetrack between floats and doubles. The size of these objects is also machine dependent. There are also arrays, structures, and unions of these basic types. So by default, an integer is 64-bit on a 64-bit operating system. That's what they're talking about when they say a 32-bit OS versus a 64-bit OS. They're talking about the size of an integer for the C compiler, literally. Or not just for the C compiler, but for the register size, the number of bits in a register that holds an integer or a float or a double, and so on. There are also arrays, structures, and unions of these basic types. So you can have an array of characters, an array of integers, an array of floats, an array of short integers, etc. Computation in the temperature conversion program begins with assignment statements. Here we go. We've got lower equals 0, upper equals 300, step equals 20, which sets the variables to their initial values. Individual statements are terminated by semicolons. Each line of the table is computed the same way, so we use a loop that repeats once per output line. This is the purpose of the while loop. The while loop operator is as follows. The condition in parentheses, so this is the condition, is tested. If it is true, Fahrenheit is less than or equal to the upper. So if the current temperature we're calculating is less than or equal to 300, the body of the loop, the three statements enclosed in braces, is executed. So this is the body of the loop here, right? So this is the body of our loop. Now we're technically excluding the braces, just like this expression excludes the parentheses. The parentheses denote what surrounds, right? So what's in between the parentheses is the condition being tested. What's between the braces, is the block of code to be executed. The body of a while can be one or more statements enclosed in braces, as in the temperature converter, or a single statement without braces, as in while I is less than j, I equals 2 times I. Let's go ahead and let's make that program, right? So do pound include standard io.h main while, we need to do int I comma j, I equals 1, and then we can do while I is it doing while I less than j, and then I equals I times 2. Is that what we had? I don't remember. Let's go take a look at it. While I is less than j, I equals 2 times I. So I like the spaces here. And then we can printf %d, comma, I. So then we would also need to assign I. J equals 100. And we'll see how many i's there. And then we need to close our main. Notice how Vim gives us this helpful hint about the brackets and the parentheses and so forth. So okay, so we can see here it's just printing 0, 0, 0, 0. And I need to exit that program with the Control C because, well, I'm not incrementing I. Oops, I got 2 times 0. I want 2 times I. And I is starting at 1. Otherwise, we'd just be starting at 0 as well. All right, so let's try this one more time. And we don't have a line, but it's 2, 4, 8, 16, 32. So let's add a /n to the end of our line here. There we go, 2, 4, 8, 16, 32, 64, 128. Now you notice how we said, well, I is less than 128. Well, what happens in our code is, right, I equals 64 at this point. I is less than j. I equals 64 times 2, 128. And we print it out. And then we come here. Okay, we're more than 100. Doesn't matter whether we use more or whether we use greater than or greater than or equal here. But we could also, let's not do anything more here. Anyway, so it stops when it gets to it prints out the last number, which is the doubled 64. All right. Either case, we will always indent the statements controlled by the while. Note that indentation is irrelevant in C, unlike in Python. But it's good form. We'll indent by 1 tab stop, which we have shown as 4 spaces, so you can see at a glance which statements are inside the loop. All right, let's go over here to our right. So when I do vim double.c, right, and I got to do set tab stop equals 4 to make it reasonable, and I've got to do that every time. So, but I can go to my vim rc, and I can do tab stop equals 4, and it will execute that when vim starts. So now when I go I think I might be, maybe I need the set command. There we go. Now we're defaulting to 4 character tabs, or 4 space tabs, I should say. And you can use spaces instead of tabs, but we will still love you. All right. We recommend writing only 1 statement per line and using blanks around operators to clarify grouping. The position of braces is less important, although some people hold passionate beliefs. Notice here, because it's a single line, it doesn't require braces. It assumes by default, if your block doesn't have braces, it only takes the next line. The position of braces, we have chosen one of several popular styles. Pick a style that suits you, then use it consistently, right? So next line, opening brace, or same line, they have a combination between the two. Functions are on the next line. Loops are on the same line. And editors like Visual Studio, CLion, IntelliJ, make those configurable, so that's not too bad. Vim is also configurable with some extra effort. All right, most of the work gets done in the body of the loop. The Celsius temperature is computed and assigned to the variable Celsius by the statement Celsius equals 5 times Fahrenheit minus 32 / 9, divided by 9, that is. The reason for multiplying by 5 and dividing by 9 instead of just multiplying 5/9 is that in Celsius, or in C, as in many other languages, integer division truncates. Any fractional part is discarded. Since 5 and 9 are integers, 5/9 would be truncated to 0. Okay, so, right, theoretically, we could set that value as a fraction value, right? 5/9 is 0.5555. All right, let's check that out. We're going to use our handy dandy Node.js, 0.5555, etc. And you can see it rounds up to 6. I mean, it doesn't. Technically, it goes 0.555 indefinitely or infinitely or until you get sick of it. But our computer takes a shortcut and it says we'll only go so far before rounding it up. Let's see. So all the Celsius temperatures will be reported by 0. So instead of doing 5/9 times Fahrenheit minus 32, which would be 0 times Fahrenheit minus 32, we separate the 5 and 9. So we get 5 times Fahrenheit, and then we divide by 9. This example also shows a bit more of how printf works. Printf is a general purpose output formatting function, which we will describe in detail in chapter 7. Its first argument is a string of characters to be printed, with each percent indicating where one of the other arguments is to be substituted, right? So the %d, or the %s, or the %f, right? So that's kind of an escape. It says, hey, %d, this first d is going to be the first argument, the Fahrenheit temperature. This next %d is going to be the Celsius temperature, %d meaning integer. So the statement causes the values of the two integers, Fahrenheit and Celsius, to be printed with a tab/t, right? That's the escape sequence between them. Each % construction of the first argument of printf is paired with the corresponding second argument, third argument, etc. Right? So printf is a function. It's taking 3 arguments. This is the first argument. This is the second argument. This is the third argument. The first argument has a place that it's looking for 2 more arguments, and that's why we have that. They must match up properly by number and type like float or int, or you will get wrong answers. By the way, printf is not part of the C language. There is no input or output defined in C itself. Printf is just a useful function from the standard library of functions, that's the stdio, that are normally accessible to C programs. The behavior of printf is defined in the ANSI standard, however, so its properties should be the same with any compiler and library that conforms to the standard. In order to concentrate on C itself, we don't talk much about input and output until chapter 7. In particular, we'll defer formatting input until then. If you have to input numbers, read the discussion of the function scanf. So scanf is like printf. Literally, scanf is like printf, except that it reads input instead of writing output. There are a couple of problems with the temperature conversion program. The simpler one is that the output isn't very pretty because the numbers are not right justified. That's easy to fix if we augment each %d in the printf statement with a width. The numbers printed will be right justified in their fields. For instance, we might say %f, %3d, %6d/n, Fahrenheit, Celsius, to print the first number of each line on a field 3 digits wide and the second in a field 6 digits wide, like this. So, right, 3 digits, 1, 2, 3, 6 digits, blank, 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 37. Well, plus the tab, which you don't see here. So let's go ahead and add that to our program. Bring Vim back up. So we're just going to, oops, that was double. All right, so I'm going to insert this, go back to command line and delete this. So %3 says make this column, the first column, 3 digits wide, and the next one 6 wide. Oops, how did I get back in here? All right, temperatures. Warning specifies int. Oh, because I switched back to floats. Or I switched back to integers instead of floats. All right. So obviously we've got a gap here, and I'm not doing dash t. So we'll go back to decimal, and we can do that just as easy here by declaring these as type integer. Compile and run, and now we can see it's formatted and aligned prettily. Computation and temperature conversion program begins with the assignments. Wait. Somehow I got out of order. Width and precision may be omitted from a specification. %6f says the number should be at least 6 characters wide. 0.2f specifies 2 characters after the decimal point, but the width is not constrained. %f merely says to print the number as floating points. So let's go back and look at this, right? Oh, so I guess I skipped ahead. But all this is doing is it's converting these to floats. And note that they also changed lower and upper and step to a float as well. So 0% F is actually about -17.8. To get more accurate answers, we're going to convert to floats. Okay, so let's do that. And note that my program's a little bit out of sync with theirs. I wonder, does this work here? That's a comment. That's annoying. I just keep hitting the wrong button. Okay, so the comment does work. I wasn't sure by going back to that old ANSI standard. I was pretty sure, but anyway, you can see we've got our float precision, and it shows 17.8, not 17. This is where 1 was 17, and 0 was also 17, because 1 is, well, let's find out. In order to do that, right, I don't want to do this outside of my loop. What I want to do is I want to, or rather, I want to create another function. And I'm going to create a function that so I'm specifying the type of this function. The type this function returns is a float. My function name is temp converter, and I'm passing 2 values, float f and float c. So now I can actually remove this line. And c equals I'm going to change this, right? I'm going to change this, call it F to C. And we actually only need 1 value. And now I can do this. oops, Celsius equals F2C Fahr. And then I can also do this at the end, is I can print F. I'm going to grab this line here. Yank it, print it, delete that. And now I can do Fahr. So I'm resetting Fahrenheit at the end like I did before. And, oops, I don't want to do that. I want to do F2C. Fahr. So I'm calling this F to C function. And I made a mistake. Fahr declared here. All right, let's see what I did wrong. Implicit declaration of function. Oh, so what I need to do is I need to put this before, I think. So I'm going to go into command mode, hit escape, D, and then I'm going to delete, it looks like 5 lines. I always have to guess that. And then I'm going to go to command mode and P. And let's see if that works, or if I have to declare, if I need to declare a function header. Oh, there's a typo. Maybe that's all I had wrong. Over here. There we go. And 1, so we can see 1 degrees Fahrenheit is negative 17.2 Celsius versus 0 is negative 17.8. So it truncated them to 17 as an integer. But if we were rounding them up, 0 would be negative 18 and 1 would be negative 17. The more serious problem is that because we have an we have used integer arithmetic, the Celsius temperatures are not very accurate, blah, blah, blah. To get more accurate answers, we should use floating point. So here we see we've declared everything as float. Notice for myself, I guess I did set these as floats as well too. This requires some changes, so we declare the types as floats. And then we do 3.0, right? So this is saying 0 decimal points, 0 decimal places in Fahrenheit, 1 decimal place in Celsius. The F is, again, for floating point. And remember, we might want to do... Okay, so I'm going to hit escape %. Oops. Command mode, colon, %. No, anyway, I'm going to change float to double. Yeah, so maybe it's % instead of S. Float, double, /G. No, wait. Is it %S? Essentially do it all. There we go. And the same thing is actually we don't need to change the %F. And we'll change this to 2 precision. And notice how this one isn't 2 precision points because we specified it separately down at the bottom. here. What if we go 4 precision points for both of them? And we can see it rounding up now, 7, 7, 7, 8. But our alignment is a little messed up. So if we do something like this, %8.4, I think that should cover us. One, 2, 3, 4, 5, 6, 7, 8. Okay, so with negative, do we actually need 9 to get it? Let's just to be on the safe side. Let's do 10. No, let's see if 9 does it. All right, so now we see everything with the minus sign. It's all lined up on the decimal point here because of the length, right? So we've got up to 9 digits. 1, 2, 3, 4, 5, 6, 7, 8. Anyway, and we see our floating point. So we can see our double precision. Let's clear this. So we've run this as doubles. If we change these back to floats, so %s double change to float. We'll write that change. We'll run it, and we can see here. Is everything the same? 8, 8, 9, 7, 7, 7, 8. I guess because, right, we're truncating our precision before we get to our errors, which were the 6 decimal places. Anyways, this is much the same as before, except Fahrenheit and Celsius are declared to be float, and the formula for conversion is written in a more natural way. We're unable to use 5/9 in the previous, so note here, 5.0/9.0, right? Because we're using floats or doubles, that, right, remember 5/9 as an integer is 0, but 5/9 as a decimal is, or as a floating point is 0.555. So now we can say our conversion function, oops, it's up the top here. We force it to be, right, these are constant numbers, but by putting a decimal, we're saying, yes, it's a float. And now we can make this, right, it's a little easier to read, 5/9. Let's go back over here and change our decimal places back to, oops, back to 2 points of decimals. Just so we see that we made our change. Oops, I accidentally deleted my asterisk. So I'm jumping around here with that slash to try and get to this. Okay, should be in the right place. There we go, we've got our 2 decimal places, and everyone's happy. I'm happy. These numbers don't look good to me, though. Right? Yeah, those numbers are like way off. Oh, we need to put them in brackets. Or in parentheses, right? Mathematical order of operations per, whatever. Oh, I've got an extra /9 here. Negative 17.78, and you can see it rounds up. When it's more than 5, 5, 6, but when it's less than 5, 4, 4, it doesn't round up. Okay. We've definitely belabored the temperature point, but it's good practice. It's helping me get a little more familiar with Vim, if nothing else. A decimal point in a constant indicates that it is a floating point. So 5.0 divided by 9.0 is not truncated because it's the ratio of two floating point values. If an arithmetic operator has integer operands, like plus, minus, multiply, divide, an integer operation is performed. If an arithmetic, operands, so 5 and 9. If an arithmetic operator has one floating point operation and one integer operand, however, the integer will be converted to floating point before the operation is done. So if we had written Fahrenheit minus 32, the 32 would be automatically converted to floating point. Nevertheless, writing floating point constants with explicit decimal points when they have integral values emphasize their floating point nature for human readability. So you can see they did that here. So we can be more explicit about this here. And our output didn't change. That's good news. Okay, 32 would be automatically converted. The detailed rules for when integers are converted to floating point are in chapter 2. For now, notice that the assignment Fahrenheit equals lower and the test, while Fahrenheit less than or equal to upper, also works in the natural way. The int is converted to float before the operation is done. What int? None of these are ints. But the way I had it before is lower, upper, and step were ints, and they still can be. The print conversion specifies %3.0f, saying a floating point number here, Fahrenheit, is to be printed at least 3 characters wide with no decimal point, 0.0, and no fractional digits. %61f describes another number, Celsius, that is to be printed at least 6 characters wide with 1 digit after the decimal point, or in our case we have 2. Is that right? Do we have 2 or 3 right now? We have 2 right now. The output looks like this, and it aligns on the decimal point there. Width and precision may be omitted from a specification. %6f says the number is to be set at least 6 characters wide. 0.2f specifies 2 characters after the decimal point, but the width is not constrained. %f merely says to print the number as a floating point. All right, so here's some examples. Among others, printf also recognizes %o for octal. That's an 8-digit or a base 8 number, 1, 2, 3, 4, 5, 6, 7, 8. Or more accurately, 0, 1, 2, 3, 4, 5, 6, 7. %x for hexadecimal. I'm losing my voice. %c for character, %s for string, and % for itself. All right, exercise 1.3. Modify the temperature conversion program to print a heading above the table. Write a program to print the corresponding Celsius to Fahrenheit table. We're not going to do that because my voice is dying. I'm overheating, and it's time to take a break. We'll see y'all for the next part where we learn about the for statement.